Now we'll be talking about combinations of functions. So we could have a sum of two functions, difference, a product, or a quotient of two functions. And just a little note about the notation. So for example, the sum, I could ask you for f plus g. I could say, what's f plus g of x? And those are saying the same thing. So those are equivalent notations. One is a little more formal, the other one's a little more informal. But both of them are asking for the same thing, the sum of the two functions, f of x plus g of x. And you'll see corresponding notations for the difference, the product, and the quotient. In terms of these four types of combinations, I also want to discuss the domain. So we're going to be finding domains for these combination functions as well. And what I want you guys to think of is, in general, you always start off saying like, okay, domain, all real numbers. And then you look for things that are excluded from that domain. So for the domain of these combination functions, start off saying, okay, everything goes, and then look for any excluded values that come from the domain of f or the domain of g. Anything that's excluded from either of those functions should also be excluded from the domain of the combination function. And one further restriction, when you get to your quotient function, note that g of x can't equal 0 because g of x is in the denominator. So whatever function is in the denominator, you also have that additional restriction on your domain that denominator function can never equal 0. So any x value that creates a 0 in the denominator also has to be excluded. Okay, so for number 9, it says let f of x equal 3x minus 1 and g of x equal x minus 5. Find each of the following. So part A says find f plus g. So your f function is just 3x minus 1. Your g function is x minus 5. You're adding those together. We're basically just combining like terms here mechanically. So 3x plus x gives me 4x. Negative 1 plus negative 5 gives me negative 6. So f plus g equals 4x minus 6. Okay, so what's the domain of this function, this combination function? Well, just as a reminder, f of x, the domain would be negative to positive infinity, all real numbers, no restrictions there. It's a polynomial function. Same thing for g of x. The domain would be negative infinity to positive infinity, no restrictions, all real numbers. The combination function is also a polynomial function, so the domain has no restrictive values, no excluded values. So we get negative infinity to positive infinity. All right, so next up, we have our difference function, f minus g. So we have our function f, which is 3x minus 1, our function g, which is x minus 5, but now we're going to be subtracting. So I'm going to put parentheses, especially around that second function, to denote that I'm going to distribute that negative sign. So distributing that negative sign, now I have 3x minus 1 minus x and plus 5. And now that we've changed those signs, combining like terms, 3x minus x is 2x, negative 1 plus 5 is plus 4. So f minus g equals 2x plus 4. All right, as far as the domain, once again, we had two polynomial functions that we were combining. The combination function is also a polynomial function, so our domain is still negative to positive infinity. No restrictions on the domain. All right, so next up we have our product function, f times g. So here I'm going to take my f function, which is 3x minus 1, multiply it by my g function, which is x minus 5. And multiplying these two together, I'm going to distribute out, FOIL out. So this gives me 3x squared minus 15x minus x. You could call that a minus 1x if you want. And then negative 1 times negative 5 is plus 5. So this gives you 3x squared minus 16x plus 5. So that's our product function. okay? As far as the domain, f has no restrictions in its domain, g has no restrictions in its domain, f times g is also a polynomial, so the domain, again, no excluded values, negative to positive infinity. And then finally, we have our quotient function, f divided by g. So f is 3x minus 1, g is x minus 5, and we're actually finished. That's our quotient function. Whenever you write out these quotient functions, I do want you to consider whether you can factor the numerator and or the denominator and then cancel to simplify. So always consider whether that's a possibility, but in this case we can't cancel or simplify anything. All right, so we know that f has no domain restrictions, g has no domain restrictions, but if we look at the composite function, now we do have a domain restriction that x can't equal 5, right? If x minus 5 is set equal to 0, then x equals 5 would make that denominator 0, right? We know that our denominator is not allowed to equal 0, so that means x is not allowed to equal 5. So we need to keep this restriction in mind for our domain. This is where g of x would equal 0, right, at x equals 5. So we have to exclude an x value of 5 from our domain. So I'm going to reflect that by writing our domain from negative infinity up to positive 5, rounded parenthesis because we can't equal 5, union symbol, and then 5 to positive infinity. So that will be our domain. Any real number is fine except for 5. And sorry, let me just redraw that because it kind of looks like a square bracket and that wasn't my intention. Just to make sure. So union symbol, rounded parenthesis, 5 to infinity. So make sure it's rounded parentheses, no square brackets. Okay, so moving on to number 10. We have the same f and g functions. It says find each of the following. So part A says find f plus g of negative 3. So I want to mention that you have two options here. Option 1 is, so I'll just put method 1. F plus g of 3, you can individually find f of negative 3. You can find f of negative 3 and g of negative 3 and add those together. So if you found f of negative 3, that would be 3 times negative 3 minus 1 using my f function here. So that's negative 9 minus 1, which gives you negative 10. And then g of negative 3 using our g function here, that would be negative 3 minus 5, which gives me negative 8. And if I add negative 10 plus negative 8, that gives me a grand total of negative 18. So that's one way to find f plus g of negative 3. Method 2, and I'm going to go out of order, but I'm going to write method 2 above method 1. Method 2 is earlier in part A, we got that f plus g equals 4x minus 6. So we know f plus g equals 4x minus 6. So f plus g of negative 3 would equal 4 times negative 3 minus 6. Just replacing this x with the negative 3. This gives me negative 12 minus 6 for a grand total of negative 18. So we end up with the same answer no matter what. Either method is fine. If you've already found your combination function, that might be more efficient to just plug x into that. But you can also evaluate each function separately and then perform whatever combination, in this case, adding the two results together. So for B, f divided by g of 0, that's the same as f of 0 divided by g of 0. So either way, we're going to get our f function 3 times 0 minus 1 over our g function 0 minus 5. We end up with negative 1 divided by negative 5 for a grand total of positive 1/5. All right, for C, It's asking for fg of 7, so f times g of 7, our product function. So one option is we could take our function from part C up here. We already found that product function. So in your calculator, evaluating this at 7, you could do 3 times 7 squared minus 16 times 7, and then plus 5, and that gives you 40. Okay. Or if you evaluate these separately, this should also be equal to f of 7 times g of 7. F of 7 would be 3 times 7 minus 1. 21 minus 1 is 20. And then g of 7, 7 minus 5 gives you 2. And again, 20 times 2 gives you 40. So either way would be fine. And then finally, we have part D, g over f of 5, g divided by f of 5. So if we put our g function up top, x minus 5, if I'm evaluating this at an x value of 5, I have 5 minus 5 up in the numerator. In the denominator, if I'm putting my f function 3x minus 1 in the denominator, I have 3 times 5 minus 1 in the denominator. 5 minus 5 gives me 0. 3 times 5 is 15 minus 1. 0 divided by 14. And that equals 0.